company mistake.
So, I will start again. Hello, assalamu alaikum. Hello, everyone. Today, I'm gonna talking with my group about our engineer talk for task one. This one, my group member. Next. Okay, this one our agenda. We will describe it in this presentation. The first one is overshoot life, and the second one is a career and instrumentation control engineer. Number C is about the strip unit control system, and the last one is about field instrumentation and process industries. Next.
Offshore life. Okay, offshore life got 4 types of offshore life. There is FPSO, FLNG, and central processing platform. Then the third one is drilling rig and barrage or boat or tanker. So today I want to explain about FPSO and FLNG and central processing platform. There is a working hour is a 24 hours operation. There is a 2 shift is 6 a.m. to 6 p.m. then 6 p.m. to 6 a.m. Then for drilling range and barrage boat and tanker is working hour is 24 hours operation and 2 shift. There is a 6 a.m. and 6 p.m. to 6 p.m. to 6 a.m. So for meals is 6 times every 3 hours will provided. Okay, then the third one is offshore rotating for regular crew or production maintenance crew is 14 days working and 14 days off for FPSO or FLNG and central processing platform. Then for drilling rig and barrage or boat tanker is offshore rotation for regular crew and production maintenance crew is 20 days work and 20 days off. Then for barrage and boat tankers is a different. There is a 6 weeks, 6 weeks days work and 6 weeks days off. Then for facilities is a recreation, entertainment, Wi-Fi, tables, tennis, pools, snookers, table, and PlayStation or Xbox game, futsal court, jamming studios, gymnasium, cinemas, and with TGVs or GSC standard swimming pool. Therefore, that is for FPSO or FLNG. For central processing platform also same. For drilling rig and barrage boat tanker is reaction entertainment, Wi-Fi, pools or snookers, tables, gymnasium, and TV. That's all. Other slides, please.
Okay, next slide about is career as an instrument and control engineer. There is 5 instrument and control engineer. Next slide. First is operation and maintenance. There are so many type of operation maintenance. The example is preventive maintenance, maintenance plan, maintenance contract management. The operator of the plant or platform is petrochemical plant, refinery plant, and offshore platform. Next. Second is design and engineering. Prepare the instrument as specification, design system architecture of control system, and sizing control wave, shutdown waves. Third slide.
Third slide.
Third
Please.
slide about the construction and fabrication. A project management team plan and monitor progress on construction and installation activities, and manage contractor and subcontractor. Next. Next slide about commissioning and startup. Functional test all the new field instrument and control system installed at the plant. Example at flow level temperature transmitter. Function testing all the logic programming for ICSS as per the drawing and design document. Third is preparation of the startup and commissioning procedure. Next slide about system integrated or system fabricated. Okay. System integrated is the company who design, fabricated, and perform logic programming for control system. Example like distributed control system, fire and gas system. The engineer from system integrated will perform the commissioning and functional tests. And last, normally the position of position in project engineer or system engineer or field service engineer. Okay, that's all. Next slide.
Okay. My name is Jaysuren. My metric number is B08191788. Today I'd like to talk about a distributed control system. It's a call about DCS. DCS is a distributed control system is a platform for the automate control and operation for a plant or industry process. It also known as integrated control and safety system, ICS. Next slide. This is the PLC and SCADA system for the company. Next slide. This is the map for how the system works and the flow of the system from where to where. Next slide. DC component consists of first is controller, CPU, main processor. Second is the I/O modules. Third is communication modules. Fourth is engineering workstation. Fifth is operator control station. HMI, human machine interface. Next slide. This is the image for the CPU processor module. And done CPU module, CPU main processor. Okay, next slide. This is the image of I/O module. Analog input, analog output, digital input, digital output. Next slide. Traditional I/O modules. This is the image for the traditional I/O module. We have a giant junction box, junction safety manager, system integration cables. Okay, next slide. This is the image for universal I/O modules. Next slide. Engineering workstation and HMI. Next slide. This is the communication module used to communicate with other DC system or PLC using modules Proteus bus RTU, Proteus bus RTCP. Next slide. This is the communication with other brand of PLC or DC using same language with the modules protocol. Next slide. Instrument signal. The first is analog transmitter, current and voltage process pneumatic signal 0.2 to 1 bar. The digital is limiter switch, contact open or close relay on off. Next slide. This is a block diagram for the process controller with the process plant, measurement, operator control system, and final control elements. This is the block diagram for the process control. Next slide, Ikram will present it.
Okay, my name is Ikram Hamza and I'm going to present about the field instrumentation in process industries. Okay, so instrumentation, equipment used for measurement, monitoring and control the process plant. So the temperature, pressure and level is the instrument for measurement and the flow and valve is final control element. So piping and instrumentation diagram, PNID. Detailed diagram in the process industry which shows the piping and vessels in the process flow together with the instrumentation and control devices. So this is the image on how it will look like for the piping and the instrumentation diagram. Okay, so this is the bigger image of how the flow is going to be and how and where will it flow, the piping, the instrumentation, all of it. So this is the temperature transmitter. So temperature transmitter just measure the temperature on the process. Remote and direct mounted type, thermocouple, high temperature RTD, maximum is 1000 degree Farad or 540 degrees Celsius. Next is the pressure transmitter. The pressure transmitter measure the pressure inside the pipe or vessel. The unit used is KPAG or BARG, diaphragm with capillary or tubing type. Flow transmitter. So flow transmitter has 4 main points: orifice flow meter, vortex flow meter, turbine flow meter, and Coriolis flow meter. So as you can see, orifice flow meter is hazard symbol, so it's dangerous and we must properly do. Level transmitter is also having a 4 different main point: differential pressure level transmitter, displacer level transmitter, float type, and guided wave radar level, non-contact radar level. So this is the image on where the transmitter, the pressure level, the guided wave radar, the float type will be placed in a tank. This is the DP level transmitter and this is the formula used to calculate on the dry leak calculation. So this is the guided wave radar level transmitter. As you can see, non-contact radar liquid level measurement and the guided wave radar liquid level measurement. So it both has a different type of measurements. This is the wireless transmitter. So we have many examples of wireless transmitter. Example is smart wireless gateway, 4320 on-off control, core lock. This is all the types of transmitter that are being used in the industries nowadays because it is wireless. Okay, on and off shutdown valves. This is can be found at many places. It is for emergency, to isolate process, for fail close, for control from DCS or shutdown system, driven by pneumatic instrument air. It has 24 volt DC supply from DCS or SDS to solenoid valve. Solenoid valve will open and supply the instrument air to shutdown valve actuator. So this is another type of valve, blow down valves. It is also for emergency, depressurized process line, in case of fail open, control from shutdown system, driven by pneumatic. This is also using air and 24 volt DC supply from DCS to solenoid valve. Solenoid valve will open and supply the instrument air to the shutdown valve actuator. This is another type of control valve. This is also for pressure control valve, temperature control valve, flow control valve, level control valve. This is also from, the control is from DCS, driven by pneumatic. And the supply is different. It is 4 to 20 milliamps to IP converters positioners. This using a different type of current supply, and is also all the same but different type of current supply. So based on what we have learned the different types of valves, the different types of transmitters. We have learned about different types of the input output, and we have also learned about the offshore and onshore works. So I think it will be helpful for us when we are graduating and doing our practicals, internship, and also it will be helpful for us as we will work after this. After we have finished our practicals, we will actually work, and this is all very connected to our studies, and the talk that was done was very helpful and beneficiary for us, as we have learned a lot from the talk, and we have learned a lot by presenting again about the talk. So I think that's all from us. Do you have any question, guys?
No.
No.
Okay, so that's all from us. Thank you very much.
Thank you, Ikram. Thank you, everyone.
Thank you,
Thank you.
everyone.